Okay, guys, so your math support warm-up is right here. It was asking you to go ahead and look at this and think about what is the multiplier and what is the y-intercept. Okay, so other terms we use for this, for the y-intercept, are starting value, and the multiplier, another term, is common ratio. Often in the Khan Academy videos, you'll see common ratio. But we've talked about it as a multiplier before in Chapter 5 when we talked about sequences. Arithmetic sequences are linear. Geometric sequences are exponential, right? So this is what we're talking about. We've kind of done this before. It's just in a new way. So your A in this case is your y-intercept. Your B in this case is your multiplier. So it's a little different. I know in linear, B is the y-intercept. We have to remember that it's not the same in this. Okay, so we're going to identify each of our y-intercepts. So for this one, 5 is our y-intercept, 2 is our multiplier. I don't know if you noticed this, but when you come down here and do D, you're going to see that I actually used the same information. This is just presented in a table, and you're trying to figure out what the multiplier and the y-intercept are. So these are actually the same, A and D. Coming down here, let me go ahead and do this. So then we're talking about B, this one right here. A is 3, our y-intercept, and then 6 is our multiplier. And so this one is not as steep. This one's a much more steep curve because the multiplier is larger. Over here, we have a multiplier that is 1/2 with a y-intercept that's 4. And when we have a multiplier that is a fraction between 1 and 0, that means that the graph would be decreasing. When we have a B that is greater than 1, that's going to be increasing. Okay, and that the smaller the fraction, the bigger the denominator, so the smaller the value of the fraction is, meaning the closer to 0, the steeper that decreasing curve will be, and the larger the B value, when it's greater than 1, the steeper that increasing curve will be. Okay, so let's look at these tables. So we're looking at our x's are just going up by 1, just like sequences, but we're looking at our multiplier here. How is this changing? So we can just eyeball it and see that from 5 to 10, what do we need to do? We're multiplying by 2. But if that's challenging for us, another way we can do this, sorry, my dogs are making noise, is that, hey guys, stop, is that we have, we look at one term and we divide it by the previous term, and that gives us that same multiplier. Same here. We're looking at this and we're seeing, oh, I think this is multiplying by 6. But if that's hard for us, we can take any term. So I can take this term right here. Sorry, that should be a 3. 18 divided by 3 gives us 6. Or I can take this term right here, and I can take 648 and divide it by 108, and that gives us 6. I can also take, guys, sorry, my dogs are making noise. I can take 108 divided by 18, and that will give me 6. Stop it, Noah, little bear. Okay, fun from working at home. Over here, I don't want you guys to get confused. If you see what I'm doing, I'm taking the term and dividing it by the previous term, so we don't get a multiplier of 2, but we get a multiplier of 1/2. Little bear, stop. Okay, so last thing I want to do is today we're going to continue to learn about exponentials. Our notes are when we're looking at graphs, we can identify the y-intercept, our value, our A value, by looking at where the curve crosses the y-axis. Shh, stop. Little bear, go outside. So I graphed this graph right here, and this one's increasing, and I have these 2 points. So I'm taking this 5, okay, this is 1 point, and I'm taking this 10. So I want to use this term and work my way backwards from right to left. So this is my this is my term. I'm going to divide by this term. Okay, so what I get is 10 divided by 5. That gives me 2. That's my multiplier. Okay, so what I wrote down here is I can then also see my A, my intercept. So I'm able to graph my, or come up with my equation from my graph, which is y equals 5 times 2 to the x power. So if you look at this, A, D, and this example 1 are all the same information, just represented in different ways. Okay, I only represented this equation with the table, but then over here, I represented C, F, and example 2 are all the same information. But you can just come up with this by looking at the graph I've plotted. And what I'm going to do again is I'm taking the second term, so my x is 1, going back to x is 0. So I have 2 divided by 4 is giving me that multiplier of 1/2, just like I did with the table. Okay, I'm taking a term and dividing by the previous term. Taking a point, my y value, and dividing it by the previous y value's point. Okay, I label them like this. So you can see that I'm taking y2 and dividing it by y1. I'm going to add that right here. y2 divided by y1. Okay, I hope this makes sense. Come to my office hours 1 to 2 on Thursday, or email me anytime if you have questions.